Good morning, everyone. Myself, Monica Nansapriya, Assistant Professor in Department of Electrical and Electronics Engineering. In this semester, I'm handling Basic Electrical and Electronics Engineering, W25C01 in the Regulation 2025. In this session, we are going to discuss about the series circuits. Series circuit is a circuit in which the components are connected end to end, forming a single path for current flow. So, what are the key characteristics of a series circuit? We are already discussed earlier for a series circuit. In this series, the components share one common node and no other element is connected to that node. So the same current flows through all the components. So only one path for the current flow. So see the circuit, we are having the resistor R1 and R2. The same current flows through all over the circuit. So what is the current flow? So this IS is equals to, that is the source current is equals to the current in the resistor R1 and the current in the resistor R2. So that we are denoting here IS is equals to I1 equal to I2. So source current is equal to the current through the resistor R1 and the current through the resistor R2 because the current has only one path to flow and it cannot split. Next one is a parallel circuit. In this parallel circuit, we are having the components are in parallel and it can share the two nodes side by side, in which the components are connected by side across the same two nodes. Here the key characteristics are share two common nodes and the same voltage which is applied across the R1 and R2. The source voltage which is equal to the voltage drop in R1 and the voltage drop in R2. So the current divides among the branches. If there is a source current is starting from the source and the current will get divided to the R1 and R2. So in parallel circuit, the current will get divided. While in the series circuit, the voltage will get divided. So multiple paths for the current flow in the parallel circuit. But the voltage path is similar. So Vs is equals to V1 plus V2. Then series resistance. In this resistance, we are having two resistors which is connected in series. So we are having we are converting one equivalent resistor, that is R equivalent is equals to, just we have to add the two resistor for the series resistance R1 plus R2. Then for the parallel resistance, for two parallel resistance, we are converting into the R equivalent, that is effective resistance is equals to 1 by R1 plus 1 by R2, the whole inverse. So what is the R1 R2 divided by R1 plus R2? Then voltage and current dividers. What is voltage divider? Why voltage is same in parallel resistance? Why voltage is same in the parallel resistance? Because each branch is directly connected across the source terminal, so that the voltage is same for the terminals. Then what is voltage dividers? The voltage divider rule, which is applied only in the series circuit. For the concept, the voltage divides proportional to the resistance. If two resistance are connected in series. So what is the formula? The current I, how the current will be calculated? So current is equals to the total source Vs divided by the sum of all the resistors, that is R1 plus R2. By Ohm's law, V is equals to IR. So I into RN. So what is V1? V1 is the source voltage. We have to calculate this V1 means what is the formula? Vs, that is the source voltage divided by R1 plus R2 into that particular voltage of the resistance. So V1 is equals to Vs into R1 divided by R1 plus R2. If you want to calculate V2 means V2 equal to Vs into R2 divided by R1 plus R2. This, the very important concept is, if we are having a larger resistance, we are having the larger voltage drop, and we are having a smaller resistance, we are having the smaller voltage drop. Then this is the voltage divider. In general, this is a problem for the voltage divider. In general, the voltage across one in a series of the resistor. We are having the series resistor of R1, R2, R3 and R4. So we have to find out V1, V2, V3, V4. Here we have to find out V3 itself. So how we are finding? What is the source voltage? Here we are having the source voltage of 16. What is the formula? Source voltage into the respective R1, respective resistor divided by total number of resistors, sum of all the resistors. So if we are calculating V3 means we are taking as a resistor value as 300. So V as a 16. So 16 into R3. What is R3? 300 ohm. So 300 divided by sum of all the resistors. That is 1 ohm, 1 kilo ohm plus 200 ohm plus 300 ohm plus 100 ohm. So what is the value of its 300 divided by, we have to add these all resistor value, that is 1.6 kilo ohm. So we get the answer 3 volt. Next is the current divider. What is the current divider? Current divider rules which is always be possible for the parallel circuits only, because current divides only in the parallel circuit. In series circuit, the voltage only divide. The current will not divide. But in parallel circuit, the current divides. The voltage should not divide. So the current divider rule which is to be suitable for the parallel circuits only. So current divides inversely proportional to the resistance. So what is the formula? What is the formula for the current divider? If we have to find out this I1, this is I1 current. We have to consider this is I1 current, this is I2 current. If we want to calculate this I1 current means you have to, the formula is this total current IS into the opposite resistor. If you want to find out this I1, but you have to write R2. This is the opposite resistor divided by the total sum of all the resistors. Okay. If you want to find out, again I'm telling, if you want to find out the current I1 in the resistor, now this in this part, the I1 current is flowing. So if we want to find out the current I1, the formula is the total current into opposite resistor. This is the opposite resistor for the I1. So opposite resistor divided by the total number of resistors. So that here they are writing IS into, that is total current, IS into opposite resistor. What is the opposite resistor for I1? R2. So R2 divided by R1 plus R2. So that if we want to find out the current I2 in the resistor R2, so what is the value? The total current IS into, what is the opposite resistor for the current I2? R1. So R1 divided by R1 plus R2. So this is the current divider formula. Next, this is the current dividers. This current through one of the parallel resistor is given by, so I1 is equal to total current I into R2, that is opposite resistor divided by total sum of all the resistors. The I2 is also similarly, I2 is equals to I total into R1 divided by R1 plus R2. One of the two resistors may be parallel combination of multiple resistors. Then how it can be generally considered as IN is equals to I total, that is total current, into conductance divided by sum of all the conductance. Conductance is nothing but the value of the resistance only, but in the reciprocal form. That is known as the conductance. We have to find out the current dividers into two different methods. One is the current divider method, and another one is by using conductance value. So in here we are finding that smaller resistance gives more current and the larger resistance give less current. So first the problem, that's R equivalent. First we are having 300 ohm and 100 ohm resistors are connected in parallel. In this circuit we are having 300 ohm and 100 ohm which is connected in parallel. So we are simplifying this 1 by 300 plus 1 by 100 is equals to 75. That is R1 R2 divided by R1 plus R2. R1 means 300 into 100 divided by 300 plus 100. The value is 75. We get the value 75. So we are having, eliminating this resistor by combining the, by using the parallel formula. So we are having 200 ohm and 75 ohm. Here we have to find out the current, that is I1 current and I2 current. How we have to find? If you want to find I1 current is equals to, I1 is equals to total current. What is the total current? I22. So 22 into the opposite resistor value. What is the opposite resistor? This is the opposite resistor. So 22 into 75 divided by 200 plus 75. This is the value of the I1. Again, I am telling we have to in this circuit they are giving three parallel circuits. We have to find out the current I1. So first, what we are doing, we have to eliminate the one resistor by using the parallel equation R1 R2 divided by R1 plus R2. So 300 into 100 divided by 300 plus 100, we are getting the value 75. So we are eliminating one resistor. So we are now we are having 275. So in this 200 ohm, we are the current flowing through the 200 ohm is I1. The current flowing through the 75 ohm is I2. So what we have to get, the total current, that is if we want to get if we want to find I1 means the total current. What is the total current? 22 into opposite resistor, other resistor. What is the opposite resistor? 75 ohm. So 75 divided by 200 plus 75. So the answer is, by using calculus, we are find out the answer, that is I1 is equals to 6 amps. The in this topics, what we are discussed about the session, that is series circuit, parallel circuit, and the series resistance, parallel resistance, and how the current divider rule and voltage divider rule we are getting with the practical problems. These are the topics we have discussed. These are the references. Thank you. Thank you for watching this video. We'll see you on the next video.